things happened. Okay, well, Philip Lawn, just as a quick introduction, is an ecological economist. We've been hearing quite a bit about that from Hayden. He's currently at Torrens University. He has worked also with the Centre of Full Employment and Equity at the University of New South Wales, Newcastle, Australia. And he's also done research with the Global Institute for Sustainable Prosperity and is a member of the Wakefield Futures Group. He's, of course, an author and has published over 9 books and numerous articles. And we're very happy to have him here to present as one of Australia's leading ecological economists. And over to you, Phil.
Thank you, Matthew. So if I just put up my... what? I should put up hit share screen. I'm not...
Yeah, sure. Well, you go into your PDF, go to your PowerPoint, and then you can, when it's opened up on the screen, yeah, here we go.
Okay.
Excellent, we're off.
Oh, great. Oh,
don't maximise.
No, I won't.
Yeah.
Okay, so I'd just like to acknowledge the fact that I'm giving this presentation on Ghana land. So I'd like to acknowledge the Ghana people, past, present and future, and recognise the fact that where I'm giving this presentation, well, one could argue was taken from those people, and so therefore I'm quite privileged to be presenting where I am in a very pleasant part of Ghana land. So what I plan to do today is to give a basic introduction to the steady state economy and explain why we need to make the transition to a steady state economy. And I might say a few things about how we might go about doing that. And I'll, okay, so to do this, right, I'm trying to advance it and it doesn't seem, okay, fine.
Yes.
All right. Yeah, no, it's working. Okay, so what I plan to do, I want you to imagine that perhaps you're doing a mainstream economics degree or an economics degree, but not at any university. You're going to be doing an economics degree at an unusual university where perhaps you'll start off learning some mainstream economics at first year level. You'll move to second year level. You'll learn some environmental economics, which, as I'll point out, is really mainstream economics that just takes into account to some extent the importance of the natural environment. So that's at the second year level. And then when you move to the third year level, you'll study ecological economics. And it's when I look at ecological economics that I'll be able to properly present the argument for a steady state economy. So you'll be privileged for studying at this university because there's very few universities where you can study ecological economics. You can study mainstream economics and your mainstream environmental economics, but there aren't many in the world where you can study ecological economics. So let's imagine that you're beginning at first year and you're studying Econ 101. So that's the mainstream approach, or what Hayden referred to perhaps as neoclassical economics. And I'm going to show you a basic textbook view of the economy. So the economy is treated as an isolated and independent system. So you've got that rectangle there representing the economy. It's completely independent. It's independent of any other sort of system, including the natural environment. And within this economy is a private sector that consists of firms or businesses. It also consists of households. Households own the factors of production. So by factors of production, we talk about human-made capital, such as plant, machinery, and equipment, provide the labour and own the natural resources. And they supply these factors of production to firms and businesses. So firms utilise the factors of production to produce goods and services, and that's referred to as the national product. So that's one way of measuring what's referred to as GDP, gross domestic product, sometimes referred to as the national product. For the privilege of using the factors of production, firms pay the factors of production for their use, so that becomes income. That's another way of measuring GDP. using the income approach. So that is payments that go from firms back to households, and households use that income to purchase the goods and services that have been produced. Sometimes within this model, the government's included to incorporate some additional so-called realism. So it'll include government spending on goods and services and taxes, and to add further realism into the model, the rest of the world is included. So the rectangle that we had before, we might consider that to be the national economy, and that sits within the so-called global economy. So outside the national economy, within the global economy, is a place called rest of the world. And that inclusion of the rest of the world allows a nation to export goods and services to the rest of the world, and to import goods and services from the rest of the world. But essentially, if we look at it in a more simplistic form, the model that you are presented in the textbook is usually confined to firms and households. And this is referred to as the mainstream circular flow model of the economy. So it remains independent, and goods and services and income just circulate like a perpetual motion machine. So this circular flow model clearly ignores the natural environment and the economy's connection to it. So all this is happening within the economy without any reference to the natural environment and any reliance upon the natural environment for goods and services to be produced and to move from firms to households, and factors of production to move from households to firms and so forth. So this model assumes there's no need for externally derived inputs of natural resources. So there's no need for something to enter the economy from the natural environment to fuel the economic process, and nor are there wastes. So when goods and services are consumed, if they're non-durable goods or if they fully depreciate through use, they wear out through use, durable goods, they don't return anywhere as wastes. They just circulate like a perpetual motion machine. So that's the standard mainstream Econ 101 view of the economy. You can see the problems with that, as it treats the economy as an independent system and not reliant upon the natural economy. And of course, that's a mythical view, because the economic process relies upon the input of natural resources in order to continue the economic process, and necessarily involves waste that return to the natural environment. So for all that we can recycle some materials, we can't recycle all materials. There's no such thing as 100% recycling of materials, and you cannot recycle energy at all. And to recycle materials, you need to use more energy. So that's ignored with the Econ 101 mainstream approach to economics. So we then move to second year, where we learn, or we study environmental economics. Environmental economics is really just a mainstream type of approach. So again, the economy is seen from a circular perspective. So we've got the circular model within the economy, as you can see presented in the slide. There's some recognition of the importance of the natural environment. So you can see we've got the natural environment off to the side. There's some connection between the two, but the economy is considered to be only tenuously linked to the natural environment. So it's only a tenuous link. The economy is assumed to be able to grow so it can get bigger into a void. So it's growing into a void because it's still relatively independent of the natural environment, even though there's some tenuous connection, and that growth can occur at negligible take-up cost. So there's no actual cost or impact on the natural environment from the economy growing. That doesn't mean that there are no costs to the natural environment from economic activity, but these costs are referred to as externalities. And by externalities, we're talking about how resources that are used to produce goods and services are allocated to produce the different types of goods and services. So if there are any costs to the natural environment, it may be due to the fact that too many resources are being allocated towards pollutive activities, or too many resources being allocated to wasteful activities which might impose some sort of cost on the natural environment. They're just simply referred to as externalities, but there are no costs associated with the growth of the economy. So the scale of the economy is not seen as a problem in terms of environmental cost. It's simply a resource allocation problem. So again, there's a failing there, because clearly we know that the growth of the economy, the physical scale of the economy, imposes costs upon the natural environment. It's not just due to how resources are allocated, but the sheer scale of the economy also imposes costs on the natural environment. So we now move to the third year level, where we study ecological economics, and we see something completely different. We still have the economy as a rectangle, but it now sits within, it's embedded within the natural environment. So we have something more akin to a host-parasite type relationship between the natural environment and the economy. So the natural environment's the host, and the economy is the parasite. So the natural economy is totally dependent upon the natural environment for its existence and its maintenance and its growth, if it does grow for a period of time. The important thing, of course, being that whilst the economy can grow, it can shrink within the natural environment as the economy's host is finite and it's non-growing. So that's already indicating to you, to some extent, that there's a limit to how large the economy can get. If it's totally dependent and reliant upon the natural environment for its maintenance, and the very thing that it's dependent upon is finite and non-growing, then like any parasite, the economy cannot outgrow its host. So there's a limit to how large the economy can get. But even before the economy gets anywhere near the size of the natural environment or the ecosphere, it can also reach ecological limits, and I'll come to that soon. And a way to do that is to consider what's really going on here. And so ecological economists recognize that in order for the economy to be maintained, which is made up of physical goods and human beings, so the population of human beings is also something that defines the scale or the size of the economy. We have production of new goods, which are added to the existing stock of goods. And of course, for production to occur, that requires the ongoing input of natural resources, which we might call R. And there's two types of natural resources. There's non-renewable resources and renewable resources. So we can rely upon non-renewable resources for a period of time, but not forever, because they're not replenishing themselves. We can rely upon renewable resources forever, so long as we don't extract renewable resources faster than they can regenerate. So we have production, and therefore, on the other side, we have consumption of goods and services. So we're talking about the direct consumption, destruction of non-durable goods. So when we eat food, drink fluids, burn petrol, we're talking about the direct consumption of non-durable goods. And we have the depreciation and wearing out of durable goods, which in both cases returns to the natural environment as waste. So it returns to environmental waste sinks, and that can occur on a continuous basis so long as the level of waste that we do generate remains within the waste assimilative capacity of the natural environment. The problem, of course, occurs when the level of waste exceeds that capacity, because that impacts upon the natural environment and reduces its capacity to supply renewable resources in particular, and other ecosystem services for human purposes. And of course, we've seen one of the main areas where we have a problem of exceeding waste sinks is in the area of climate change. So the excessive generation of greenhouse gases by human beings means that the concentration of greenhouse gases in the atmosphere is rising, causing to climate change, in particular global warming, because the rate at which we're generating greenhouse gases is exceeding the ability of the natural environment to safely absorb and assimilate those greenhouse gases. This input of resources and output of waste is what can be referred to as the throughput that sustains the economy. So in the same way that you and I have a throughput, we eat food, we drink fluids, we require that in order to exist. And of course, we burn energy as we exist and we undertake activities. And of course, we excrete matter and fluids to be sustained. So has the economy got some sort of metabolic rate? So there's this throughput of matter and energy that's required in order to sustain the economy, even if it's at a steady physical state. This throughput can only be increased so much. So this input of resources, output of waste can only be increased so much before it becomes ecologically sustainable. So even before the economy reaches anything like the same size as the natural environment, it can reach ecological limits because it requires this throughput to be sustained. And that rate of throughput can only be increased so much before it becomes ecologically unsustainable. I won't go into the first and second laws of thermodynamics, but the implications of them is that the matter and energy that's embodied in natural resources that are used to produce the goods that make up the economy ultimately equals the matter and energy embodied in the waste that exit the economy as goods and services are consumed or depreciate over time and become waste. Now, of course, some of the goods that we produce are durable, which means it is possible over the short term for R to exceed W. So the matter and energy embodied in the resources that enter the economy, all that will exit the economy, but they can remain within the economy for a period of time because some goods are durable before they become waste, before they wear out through use. And if over a short period of time R exceeds W, production exceeds consumption and the economy grows. So when R is greater than W, production exceeds consumption. So we're adding more goods to the economy than is being consumed and is wearing out through use, and the economy grows. However, if R is equal to W, the economy is non-growing. And a non-growing economy is a steady state economy. But of course, a steady state economy can still be dynamic. So a steady state economy still involves production of new goods and services to replace consumed and depreciated existing goods and services, so long as the quality of the new goods and services exceeds the quality of the existing goods which are consumed and wear out through use. We can maintain a steady stock of goods that qualitatively improve over time, and we can be better off. So you can have so-called development without growth. So the steady state economy can still be a dynamic economy. With a steady state economy, well, it can exist at different scales. But if you have a larger steady state economy where R is equal to W, the throughput will be greater. And so therefore will its impact on the natural environment, the ecosphere. So you can have a larger steady state economy, but it must be remembered that will require a greater rate of throughput, and that will have a greater impact on the ecosphere. So what happens to this incoming rate of resource input? Well, it's allocated to produce various goods and services. So I have arrows there directed towards the different types of goods and services that can be produced and therefore consumed or wear out through use. Those in blue represent goods with private goods characteristics, those in red with public goods characteristics. So in terms of the allocation of the incoming resources, the questions that need to be asked is what is produced? Should we produce cars, iPhones, and so forth? How many cars? How many iPhones? Should the cars be a certain type? Should they be diesel cars, petrol cars, electric cars? Should they be red or should they be blue? And so forth. So they're questions we need to ask. We also need to ask how should these goods and services be produced? So should we produce them using renewable resources or non-renewable resources? Should we use low carbon methods or high carbon methods? So how we produce the goods is very important. And of course, the other issue, another question is, should they be produced by the private sector or by the public sector? So these are questions related to the allocation of the incoming resources. The other important question from an ecological economic point of view, which is not considered as important from a mainstream perspective, is the distribution of goods and services produced. Who gets what? Should only a small percentage of the population get to consume and possess a large percentage of the quantity of goods and services produced, or should they be spread more evenly? So there's a much stronger emphasis on the equitable distribution of income and wealth with ecological economics than mainstream economics. And then there's an issue that's completely ignored, disregarded by mainstream economics, and that's the scale of the economy. That is an important issue from an ecological economic perspective. How big should the economy be? How much stuff should we produce? And how much is sustainable? So let's look at some issues, important issues from an ecological economic perspective that are important in terms of the steady state economy. Issue one, three main issues of focus concerning the steady state and the order of their resolution. The most important is the sustainable economy and the population of human beings within it. Because if you think about it, it doesn't matter how beneficial economic activity is. If it's not sustainable, it's not really worthwhile in the long run. So sustainable scale is uppermost important for ecological economists. It's not seen to be important from a mainstream perspective, largely because, as I said before, the economy is seen to be independent of the natural environment. Now, in terms of ensuring the scale of the economy and the population is sustainable, that's largely a role of governments, not the market or the private sector. And all issues related to sustainable scale of the economy and population should be based on ecological criteria, not economic criteria, and so forth. It should be on ecological criteria. The second important issue is the equitable distribution of income and wealth. Again, that's mainly the role of governments. To some extent, competitive markets can help in this regard because they reduce monopoly power. But competitive markets do depend a lot upon government intervention to ensure you have the right type of legislation to prohibit anti-competitive behaviour, so something like the Trade Practices Act. In terms of the criteria that's used when deciding what is an equitable distribution of income and wealth, again, it's not based on economic criteria, but on ethical criteria. So the first two major issues have nothing to do with economic criteria. The first, scale, is based on ecological criteria, equity on ethical criteria. So it's only once we have those two issues, problems resolved, that we can then focus on the efficient allocation of natural resources that enter the economy. And of course, this is where resources should be allocated to generate the greatest net benefits to society. Now, that's primarily the role of markets, according to ecological economists, but it must be remembered that still requires significant government intervention because markets have a propensity to fail. And it should also be noted that even the allocation of natural resources will be very much influenced by governments playing their role to ensure the economy or the scale of the economy and the number of people within the economy, the population of people, is sustainable and that the distribution of income and wealth is equitable. And that's because decisions related to scale and equity problems will influence market prices and therefore will affect the allocation of resources. So, for example, if a government intervenes to ensure the rate of resource use or the rate of throughput, as I referred to earlier, the input of resources, output of waste, remains within the regenerative and waste assimilative capacity of the natural environment, that will perhaps involve a restriction in the supply of resources that can be allocated to produce the various goods and services. That will force the price of resources upwards. That will mean that if you are a wasteful producer in terms of wasting resources, or you're not a very efficient producer, you will become uncompetitive. So resources will tend to be allocated to those producers that use resources most efficiently, or those producers that generate the least amount of waste to produce a particular type of good, or the fewest greenhouse gases. So 1 and 2 affect 3. Issue 2, recognise the economy as a subsystem of the ecosphere, which ecological economists do. Focuses attention on the overall size of the economy. I've referred to that. That's a consideration overlooked by mainstream economics. This raises 3 important scale-related questions. I'll just reiterate those. They are, how big is the economy? So we need to know how big the economy is. We need to know how big the economy can get before it becomes ecologically unsustainable. And we, importantly, also need to know how big the economy can get before growth becomes uneconomic. Now, that may not mean much to many people, might not make much sense. So let me just talk about a few important points raised by a famous ecological economist, Herman Daly, regarding economic and uneconomic growth. Most people probably never heard of the term uneconomic growth. Growth is only economic in the strict sense if the additional benefits of growth, of whatever, are greater than the additional costs. Okay, so growth is only economic if it leads to an increase in benefits that exceed the increase in costs. In that situation, where you have growth that is economic, economic welfare rises. But growth can be uneconomic. So growth in GDP will be uneconomic if the additional benefits of growth in GDP are exceeded by the additional costs. So in that situation, economic welfare falls. So it's almost always automatically assumed that growth in GDP is economic. Well, in fact, it can be uneconomic. If it increases costs faster than it increases benefits, then the growth in GDP is uneconomic, economic welfare falls, and therefore the growth in GDP is undesirable. So growth in GDP need not always be economic. And one of the indicators, alternative indicators that can be used to determine whether growth is economic or not is an indicator that I've done a lot of work on called the genuine progress indicator. So unlike GDP, which just measures or provides a monetary measure of the total volume of economic activity, the genuine progress indicator measures the benefits and costs of economic activity. It subtracts the costs from the benefits. So if growth in GDP is uneconomic, the genuine progress indicator falls and indicates that economic welfare is declining. So therefore, growth in GDP need not always increase economic welfare. So that raises an important distinction, this is issue 3, between growth and development, which is not always recognised by mainstream economists. Growth involves the physical expansion of the economy, which may or may not increase human well-being. So it's automatically assumed that growth always increases human well-being, well, since growth can be economic or uneconomic, and growth involves the physical expansion of the economy, then physical expansion of the economy may not necessarily increase welfare. And genuine progress indicator studies indicate that once countries reach a certain level of per capita income or wealth, that further increases in per capita income and wealth do not increase economic welfare, in fact, can lead to their decrease, which is a good justifiable reason, not only on ecological grounds, but economic grounds for moving towards a steady state economy. So we need to move towards a steady state economy, because once we reach this desirable scale of the economy, further growth of the economy simply makes us worse off. We can still be better off with a steady state economy. The genuine progress indicator can still rise, but that's not going to be due to increase in the physical scale of the economy, but improvements in the quality of the goods that comprise the economy and the way we organise ourselves and the efficiency with which we use resources to maintain a steady state economy. Development, on the other hand, is not growth. It involves qualitative improvement, and that by qualitative improvement, I mean improvement in the goods that make up the economy and the technology employed to produce them, in the distribution of goods within society, so that distribution of the goods that make up a steady state economy is more equitable, and in the way we order our goals. So it's also important that we order our goals so that we put our most pressing needs first and our trivial wants last. So there's not much point in producing goods that meet trivial wants if they're not meeting vital needs. And in the way we organise the economic process, so we can organise it in ways that reduce, if not totally eliminate, unemployment, which also has social benefits. Issue 4, policies to achieve ecological sustainability should be based on a few basic sustainability precepts. That's so we can remain within planetary boundaries. I'll just go through those very quickly. Firstly, harvest rates of renewable resources should not exceed resource regeneration rates. Extraction rates of non-renewable resources, which of course can't last forever, should not exceed the creation of renewable resource substitutes. And the rates of waste generation should not exceed the waste assimilative capacity of the ecosphere. So the steady state economy would be largely based on a scale where the rate at which resources are used and waste are generated adhere to these sustainability precepts so that we remain within planetary boundaries. And just finally, one way we could perhaps assist the transition to a steady state economy, we could have something like cap option trade systems. And by that, I mean cap option trade systems in relation to natural resources. So that's the input of resources and the output of waste, which can also include things like greenhouse gas emissions. We set caps, which set a quantitative limit on the rate of resource extraction, waste generation, which would be based on ecological criteria, and that limits the scale of the economy to the sustainable scale. So the steady state economy is one that's sustainable. So it's based, remember, caps on ecological criteria. In order to access resources, if you're a producer and if you're going to generate some pollution, which is inevitable, then the rights to access resources to generate pollution, which are capped, are auctioned off. They become depletion pollution rights. That generates price signals to facilitate the efficient allocation of the sustainable rate of throughput. So we, through the caps, ensure that the rate of throughput is sustainable, but to ensure that the resources entering the economy are efficiently allocated, so they go to the highest possible use values, we auction off those rights, which generates price signals, which means the inefficient and pollutive producers become uncompetitive and are weeded out. And the prices paid to acquire depletion and pollution rights, they serve as taxes. They effectively become taxes, which allow governments to provide more public goods and or compensate people on low incomes should goods prices rise. So if resource prices rise, if the cost to pollute rises, it can lead to an increase in the price of goods and services. That affects people on lower incomes more so than people on higher incomes. Well, the taxes reduce some of the spending power of wealthier people and also people on low incomes, but low income people can be compensated with tax rebates, a lower marginal tax rate on people on lower incomes. So they're less affected or not affected at all. And of course, governments are in a better position to provide more public goods, not because they'll have more, if we're talking about governments that are monetary sovereigns, more money to spend. Stephen Hale will talk a bit about that with modern monetary theory. If a government's is a monetary sovereign, it doesn't need taxes in order to spend, but the prices paid for depletion pollution permits reduce private sector spending power, which free up resources that governments can access in a non-inflationary way to use to provide public goods. And by public goods, I'm talking about green infrastructure, roads, and other important infrastructure in health and education that are required to move to a qualitatively improving steady state economy. And that's my presentation. So thank you for giving me the opportunity